Namaste children, I am Hari Prasad, your chemistry teacher. Children, today's topic is the variation of ionization energy or potential when you go down the group. Children, we already know that the factors which is going to affect ionization energy is what? One is atomic radius and another one is what, children? Nuclear charge. So the relationship between atomic radius and ionization potential is inverse relationship, and the relationship between nuclear charge and ionization potential is direct relationship. Children, out of these two, we have already discussed that atomic radius is more important, and for you to understand very easily, we'll consider only atomic radius. Now, children, for this, I have taken one elements of group 1 of the periodic table, right? I have considered lithium, sodium, potassium, and what, children? Rubidium, right? Configuration is 2-1, that is has 2 shells, and sodium is 281, it has 3 shells, and potassium is 2881, it has 4 shells, and rubidium is 28881, it has got 5 shells. Children, we all know that when you go down the group, the atomic radius is going to what? Increase. Children, if I hold like this nucleus and outermost shell containing electrons. Children, this is lithium, right? Sodium, which is bigger than lithium, then this is potassium, then this is rubidium. So conclusion from this one is, when you go down the group, the atomic radius is continuously what? Increases. So what will happen when the atomic radius increases? As the atomic radius increases, children, I have written the electron in the outermost shell, right? As the atomic radius increases, the force of attraction between the nucleus and the outermost electron is going to what? Decrease. Why the force of attraction between the nucleus and the outermost electron decreases? The force of attraction decreases mainly because of what? Increase in what? Distance. See, this distance and this distance, obviously this is more, and this is still more, and this is still more. As the distance increases, the force of attraction between nucleus and outermost electron is going to decrease. Sir, why on increasing the distance the force of attraction decreases? This we have already discussed in the previous classes. That is because of what, children? Because of screening effect, right? What is screening effect? Screening effect is nothing but the decrease in the force of attraction between the nucleus and the outermost electron by the electrons of what shells? Inner shells. This is the nucleus and this is the outermost electron, and in these things we have the electrons, and these shells are called as what? Inner shells. So these people will act as a screen between nucleus and outermost electron. Now in case of lithium, between nucleus and outermost electron we have how many screens? Look at this one screen. In case of sodium, between nucleus and outermost electron we have how many screen? One screen and two screen. That is, two people are decreasing the force of attraction between nucleus and outermost electron. In case of potassium, how many screens are there? 1, 2 and 3. Between what? Nucleus and outermost electron. In case of rubidium, how many screens are there? 1, 2, 3, 4 screens are there between nucleus and outermost electron. So when you go down the group, the screening effect is going to continuously what? Increases. So because of increase in screening effect, the force of attraction between the nucleus and outermost electron is going to what? Decrease, right? Now one simple question: out of these 4 atoms, where there is more force of attraction between nucleus and outermost electron? Anybody can tell. It is what, children? Lithium. Why? Because the distance is very, very less. Where there is less force of attraction between the nucleus and the outermost electron, right? It is rubidium. See, the distance is more screening effect. That's why the force of attraction between nucleus and outermost electron is what? Less. Now, here the force of attraction is more, means between nucleus and outermost electron. To break this force of attraction, I have to supply more energy. That is, I have to supply more energy to remove the electron from lithium. In case of rubidium, the force of attraction between the nucleus and the outermost electron is very, very less. Then to remove the electron from rubidium, I have to supply very, very less energy. In this case, I have to supply more energy, that is in case of lithium, and in case of rubidium, I have to supply very less energy. Now, we will see whatever we have discussed, it is right or wrong. Okay, children? Now, when we just go through the ionization potential values, so to remove the electron from lithium, I have to supply 5.4 electron volts. All right. Now let me just check the value of rubidium. Right. So to remove the electron from rubidium, I have to supply 4.2 electron volts. Yes. Whatever we have discussed is correct. That is, lithium is small. The force of attraction between nucleus and outermost electron is what? More. So to remove the electron, that is, to overcome this force of attraction and remove the electron, I have to supply 5.4 electron volts. Here, between nucleus and outermost electron, the force of attraction is less. So, to remove the electron, I have to just supply only 4.2. So, let us see the values of sodium also. It is 5.1, and in case of potassium, it is what, children? 4.3. So, conclusion from this one is, when you go down the group, the ionization energy or ionization potential is going to what? Decrease because of increase in what, children? Atomic radius. Okay, so this is how the ionization energy varies when you go down the group. Now, children, suppose if they ask a question in the board exam, what's question number 1? Which is the element that is having a maximum IP in the whole periodic table, and which group of elements are having a maximum IP, and which group of elements are having a minimum IP? So for that, what we have to do is that we'll just take the elements. Like, children, you also know that you have only the elements from 1 to 20. So the elements are something like this. So hydrogen, what? Helium, then lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon, potassium, and calcium. Children, we all know that across the period, the ionization potential is going to what? Increase because of decrease in atomic radius. So when you go down the group, the ionization potential is going to what? Decrease because of increase in atomic radius. Now, children, if this is the trend, hydrogen and helium, who is having a maximum IP? See, this way if you go, it will increase. Obviously, helium is having a maximum IP. Okay. Now, suppose if you go like this, right? Out of these 8 elements, who is having a maximum IP? Obviously, it is neon. Out of these elements, who is having a maximum IP? Yes, this way it will increase. So it is argon. So conclusion from this one is, in each and every period, the elements that is having a maximum IP is which one? It is what, children? Noble gases. Why noble gases? We have to supply more energy to remove the electron because noble gases have a stable electronic configuration, that is duplet in case of helium and octet in case of remaining noble gases. So conclusion from this one is, the group of elements which is having a maximum IP is group what, children? 18. Now, children, if you go this way, the IP will increase, right? Definitely. Now, the next question was, which group of elements are having a minimum IP? See, this way it will increase means obviously the one which is having a minimum IP will be towards which hand side? Left hand side. That is, group 1 is the one that is having a minimum IP. Right, children? Now, the last question. In the whole periodic table, which element is having a maximum IP? Now, this way if you go, the IP will increase, right? Helium is having a maximum IP, correct? When you come this way, that is, when you go down the group, the ionization potential is going to what, children? Decrease. So, among the noble gases are having a maximum IP. But among the noble gases, which element is having a maximum IP? So, the answer is helium. So helium is the element which is having a maximum IP in the whole periodic table. Group 1 is having a least IP and group 18 are having a maximum ionization potential, right? So I hope you have understood this one, children. We'll continue the remaining things in the next video. Thank you, children. Namaste, everybody.